Hey y'all, this is the last lesson in Module A, and we're going to talk about how do you graph two variable inequalities. So more specifically, we're going to talk about how do you graph a linear inequality, and then since we're dealing with inequalities today, we need to talk about how our answer is going to include shaded areas, and then how our line, when we graph the line, is going to be dotted versus solid, and then we're going to actually do the same thing with the absolute value. So if you had a little bit of trouble with graphing in yesterday's lesson, don't worry, you're going to get a little bit more practice with this today. So what's the difference between a linear inequality and a linear equation, okay? If you want to pause and read this to yourself, you're more than welcome to, or you can follow along with me. The essential understanding here says graphing an inequality in two variables is similar to graphing a line. The graph of a linear equation or inequality contains all points on one side of the line and may or may not include the points on the line. So, like I said, this is where the dotted versus solid comes into play, and then your answer is going to be a shaded region, as you can see from the graphs in the bottom. So a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. This line is the boundary of the graph, and the boundary separates the coordinate planes into two half planes, one of which consists of solutions of the inequality. So as you can see here, this is a lot of verbiage, and if you're an analytical learner, like you could be like, oh yeah, I'm with you. However, for everybody else and for myself, I'm more of a visual learner, so I think this will make a lot more sense once we do a couple of examples. But as you can see here, when it comes to inequalities, your answer isn't just the graph of the line. It's going to be the line, whether it's dotted or solid, and where your shading is. So on this slide, it talks about where do you shade, okay? And the textbook talks about using a test point. However, the Algebra 2 team feels as if the best way to have you all learn which area to shade is by reading the inequality statement. Excuse me. So let's look down here at the bottom at this equation. Y is greater than x minus 2. Okay, so if your sign is pointing this way, that means it is greater than. So, as we've talked about previously, if you want to graph a line, you start with your y-intercept and then you do your slope. And the line here is dotted because it is strictly greater than. It doesn't have that equals to under it. If it had the equal to under it, it would be a solid line, but since it doesn't, we have it dotted. Now the question is, where do you shade? Above the line or below the line? Well, since the equation says greater than, you're going to be greater than that equation. So hence, that's why we shade above. Same thing over here, looking at this second equation. We have less than or equal to. So that's less than because it's pointing to the left. So when I graph my equation, right, I'm starting at my y-intercept and then I do my slope. Up 2 over 1. I could also go down 2 over 1. And this is a solid line because it has that equals to a part of it. And as you read the equation, it says y is less than or equal to. It is less than. It's lower. So less than the line would be everything shaded underneath. We believe that makes the most sense as opposed to using a test point, but if you want to read the top part and learn about a test point, you're more than welcome to. However, we just feel that it's best if you just read the inequality statement. If you have a question, again, make sure to write it down in your notes so you can ask during office hours. However, we're going to go ahead and get started practicing with problem number 1. It says, what is the graph of each inequality equation? So just like we started the other day, we're going to start by graphing our equation here. Y is greater than or equal to 3x minus 1. So my y-intercept is at 0, negative 1, and my slope is positive 3. So I'm going to start at 0, negative 1. I'm going to go up 3 and over 1. Up 3 over 1. Now I can't keep going up 3 over 1 here, but I could go down 3 and over 1. Down 3 and over 1. All right. So I need to go ahead and graph the line, but I need to determine whether it's going to be a solid line or a dotted line. This is going to be a dotted line because we do not have the equal to underneath that inequality sign. This is probably one of my favorite tools. I love the line tool. It's so helpful. So I have my line graphed, and from here, all I have to do is now determine which way do I shade. Do I shade above the line or do I shade below the line? Well, the inequality statement says that this is greater than, so that means I can pick a point on that line and I'm going to shade above it. So that means the area that I would need to shade would be right here. Again, if you have a question, please note it, and I'd be more than happy to answer it during office hours. If you are ready to move on to the next one, let's go ahead and do it. It's literally the same equation, so that's helpful. I just plotted that earlier. And now, when I go to graph the line, I need to look, okay, is this a solid or a dotted line? This one is solid because of the equal sign underneath the inequality statement. So here you can see I have a solid line with my arrows at the end. And then we want to look to see which way we need to shade. My inequality statement says less than, because it's pointing to the left. So if I'm going to be less than my equation, I can pick a point and then go below it. And so that means I'm going to shade underneath that line. So if you will, go ahead and pause the video, see if you can do these two on your own. If you need a little bit more guidance, you can go ahead and follow along with me. So again, we're going to graph the linear equation here. My y-intercept is at 0, 1. So I'm right here. And my slope is negative 2. So slope is negative 2. So I'm going to go down and to the left, down and to the right, down and to the right, down and to the right. I could also go up to, but go to the left, right? As long as it's a negative slope. Okay. So now I have to determine whether this is a solid or a dotted line. It is a solid line because of the equal underneath. And then I just have to figure out where I'm going to shade. And since my inequality is greater than, that means I'm going to shade above my line. Same thing with part B. I have the exact same equation. And now let's look at the inequality statement. This is going to be a dotted line because I don't have the equal to under it. And then all I have to do from here is determine which way to shade. My inequality statement says y is less than, so I'm going to be below my line. And it's that easy. All right, let's put this into a word problem here. So it says here on problem number 2, you're going to need some space on this one because we're actually going to graph it too, and it gets a little crazy. On problem number 2, though, we're putting this into action with a word problem here. It says the map shows the number of tickets needed for small or large rides at the fair. You don't want to spend more than $15 on tickets, so how many small or large rides can you ride? So what we need to do here is look at the diagram, okay? It tells us that small rides are 3 tickets. So let's say that X is equal to the number of small rides. Okay? So for every small ride, it's going to cost you 3 tickets. And now we also notice that large rides cost 5 tickets. So let's say that that's Y. So large rides are Y. So that's going to be 5 tickets for every large ride that you go on. Now, you said that in the problem you cannot spend more than $15 on tickets. So we need to look back at the map and say, okay, each ticket costs 25 cents, right? So if I want to have my total number of rides, so between my small rides plus my large rides, I cannot spend more than we would want to put $15 on the right. However, you notice that this is in dollars, and over here in the map, it's in cents. So what we need to do is we need to multiply 15 by 4, because how many quarters are in a dollar? 4. So that actually comes out to be 60 on that right-hand side. So for every dollar, you get 4 tickets. So that's why you would have a total of 60 tickets if you spent $15. Okay. So $1 equals 4 tickets, and you have $15. So that gives us a total of, that's where my 60 is coming from. You have 60 tickets if you're going to spend less than or equal to $15. So from here, this goes back to what we did just the other day. In order to graph this, I got to get y by itself. So I'm going to subtract the 3x. So I get 5y is less than or equal to negative 3x plus 60. And I'm going to divide both sides by 5. Everything gets divided by 5. So that means I have y is less than or equal to negative 3/5 x plus 12. So what I'm going to do is I'm going to graph this equation. And when I graph it, there's something really special going on here. If I'm going to graph this equation, okay, why did I only draw the first quadrant? Okay, think about that. Why did I only draw the first quadrant? Let's think about what our axes are. The x-axis we said were the small rides. And the y-axis we said were the large rides. So would it make sense for me to have negative rides? No, that wouldn't make any sense at all. Okay, that would make no sense. So all I need here is that first quadrant. And that's kind of one of our other inequality statements that we could include here too. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. Okay? The reason that is because you can't have negative rides. We said x and y represented the rides, so we obviously can't have negative. Could we have 0? Could we not ride them at all? Absolutely. But you can't have negative rides. So I'm going to go ahead. This is going to be rough, y'all, because I don't have graph paper. Okay. I'm gonna have this go by 2s because obviously I do not have a lot of room. So what I'm going to do is I'm going to go ahead and graph my equation here. Oh man, the slope is negative 3/5. Oh, I'm going to have to go by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here we go. I'm actually going to go by 1s because I forgot my slope was so awful. Okay. So I'm going to start at 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, hey. All right. So now I'm going to go down 3 and out 5. Now this is where it gets kind of crazy because I don't have exact measured graph paper. 1, 2, 3. Oh, that's off a little bit. Okay, there's that point. Now I'm going to go down 3. 1, 2, 3. Stay right there. This is harder than I thought, y'all. Actually, that point is right there. 1, 2, 3. All right. That was a little rough, but not too terrible. I'm gonna erase that other point. I was off just a little bit. And let's use the line tool to see like how precise I actually am. Is this gonna be a solid or dotted line? It's going to be solid. And I actually don't have to have arrows on this one because like we said, we have that restriction of, oh, hey, that was pretty good, y'all. If we were in class, y'all would be clapping right now, I'm just saying. All right, so we have our equation. Again, we don't have to have the arrows at the end here because, as we mentioned, we don't have it going into the negatives at all. So then from here, all I have to do is shade. Which area would I need to shade in? Well, let's take a look here. We said that x had to be greater than or equal to 0, right? So my x and my y both have to be greater than or equal to 0. So like my y's have to be greater than or equal to 0, my x has to be greater than or equal to 0. And with my inequality equation, it said my y values are less than or equal to that equation. So I'm going to shade inside that triangle. So now that I have my graph, I think I should be able to answer the final question here. It says, how many small or large rides can you ride? Well, at most, again, this was my large on the y-axis. At most, I could ride 12 large rides, right? I can max out at 12 large rides. That means if I did 12 large, that would be no small, right? And then vice versa. Where do I cross the x-axis? I think that's at 20, if I remember correctly. So I could also do 20 small, but then no large. Okay. Was this a long problem? Yes. However, this is application. This is where you put our math that we're learning into real world situations. Okay. So on this next problem, if you will, go ahead and try this one on your own. You can go back and rewatch the other problem that I just worked out if you need to refresh yourself on, oh, wait, how did she get that again? Okay. But go ahead and try this one on your own. If you're still like I am just crazy lost, you can go ahead and follow along with me. So it says, suppose that you decide to spend no more than $30 on tickets. Ooh, $30. Okay, what are your possible combinations of small and large rides now? You can use a graph to find your answer. So again, small rides cost 3 tickets, plus large rides cost 5 tickets is going to be less than or equal to. Now remember, you get 4 tickets for every dollar. So here, we would have less than or equal to 120. You have 120 tickets. So is this equation going to look very familiar? Yes. I'm going to set this up the same way. I'm going to subtract the 3x from both sides. So I have 5y is less than or equal to negative 3x plus 120. So I have y is less than or equal to negative 3/5 x plus 24. And then you could do the same thing here. Oh my gosh. don't even think I got it all. Okay, so same thing here. You have your inequality equation. You have x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Now, when we graph this equation, we would start up at plus 24. I'm going to have this go by 2's because otherwise I'm not going to fit this whole graph in. So that's 24. Okay. So if you were going to graph this, you would go down 3 and out 5. Okay, again, I don't have super nice graph paper. However, I'm going to show y'all a shortcut. I was on the line. Ooh. Okay. Now for this problem, if you noticed, the money for our tickets doubled in price. So that just means that everything else doubled. So like this was at 12 in the last one, so now we're at 24. This is going to be at 40. Does this work every time? No, this just works for this problem because you notice that your money doubled, okay? But still, your x values, they have to be greater than or equal to 0. Your y values have to be greater than or equal to 0, okay? And then you're less than this equation. So again, you are inside that middle triangle. Okay. Perfect. All right, let's finish this up talking about absolute value inequalities. And we're going to graph these just like we did the linear equations. However, key word here, absolute value inequality. So in your mind, you know that is a V-shaped function. That is not a linear equation. So on this one, we have to do a little bit of work because you should notice here that your y values, not by itself. So we have to get the y value by itself. So let's subtract the 1 over. So we have negative y is less than the absolute value of x plus 2 and then minus 1. That's really important here, guys. That minus 1 goes on the outside. You don't do it inside the absolute value. It goes to the outside. Now from here, your y value is still not by itself, so we're going to divide everything by negative 1. And when we do that, we have now y, because those cancel. Now this inequality sign is going to flip to greater than. You should have learned back in like your previous math courses, all the way back, that when you divide an inequality statement by a negative, it flips the sign. And it sure does. Now from here, we're going to have a negative outside of our absolute value statement. Nothing changes inside here, guys, okay? Nothing changes. Everything is done on the outside. And then negative 1 divided by negative 1 becomes positive 1. So now I have an equation that I can actually graph and work with. And this is kind of like what we did yesterday. We're first going to find the vertex. So my vertex would be at negative 2, positive 1. So let's go ahead and plot that, negative 2, positive 1. And let's look at the a value here. My a value just has a negative. So that means my a value is negative 1, which implies my slope is negative 1 as well. So from my point, I'm going to go down 1 and out to the sides. Down 1, out to the sides. Down 1, out to the sides. Okay? So from here, same thing. Is this solid or is it a dotted line graph? This one would be dotted because we don't have the equal sign under the inequality statement. Make sure you have arrows at the end of your line. And then last thing, where do we shade? It says y is greater than the equation, so go to any point and go above it. So we would be above that equation. If you are still having trouble figuring out, like, how did you know that it opened down? How did you know your slope was down 1? Okay, please, please, please ask us. Okay, the A value out front tells you your slope. That tells you which direction to go from your vertex. So my A value was -1, so from my vertex, I went down 1, out 1, down 1, out 1. Okay. Let's do the same thing on this next one. If you can do this on your own, please go ahead and do so. If you need a little bit more help, okay, maybe pause it and try it on your own and then follow along with me. If you're completely lost, let's keep sticking with me right here. We're going to go ahead and get the y value by itself, so we're going to add 4 to both sides. So I get y is greater than or equal to 2 times the absolute value of x minus 1 and then plus 4. This is now in the shape of the equation that I can graph. So my vertex is at 1, 4. So let's go ahead and plot that. And then let's look at our A value. Our A value is +2. So that tells me my slope. So from my vertex, I'm going to go up 2 and out 1. Now this is going to be a solid line because I have the equal under that inequality. And again, it's a V-shaped function. I got to have my arrows. And now the last question is, where do we shade? Are we going to shade above the function or below the function? On this one, it says y is greater than or equal to, so if I go to any point and I go above it, that shows me I'm going to shade in here. All right, for this last concept, they are actually having us go in reverse. So they gave us the graph, and now we have to come up with the inequality statement. So the first thing we need to do here is identify the vertex. So my vertex is at the point 3, -2. So when I set up my equation, a times the absolute value of x minus h plus k, I'm going to plug in the 3 and the -2 for my h and k. So now this kind of goes back to what we did the other day, except now, instead of this equal sign, we have to determine whether it's greater than or equal to, less than or equal to, greater than or less than. Well, the line is dotted, so we know that it's going to be greater than or strictly less than. And it's shading above the line, so we know that it's going to be y is greater than. The last part here is figuring out that A value. So what is our slope? Well, if you look at your graph, it looks like it's going up 1, out 1. So my slope here would be +1. So if your A value is +1, you actually don't have to put anything there. It is understood to be 1. So we can check to make sure our equation, does that actually match up with what is graphed? And it does. So on this last one, see if you can try this one on your own. I would advise you to be very careful with the graph. If you still need some help with this concept, please just feel free to follow along. So we have our equation, y is equal to a times the absolute value of x minus h plus k. Let's identify our vertex here. Our vertex is -4, +3, because the graph is going by 2's. Be very, very careful there. So y is equal to the absolute value of x plus 4, because remember it's the opposite inside, and then plus 3. Well, let's look at our slope. If that's at 3, let's find another good point here. Okay. So, I have the point -4, 3, and I have another point here that looks like -1, 0. So what I can do, going back to section 2.3, I can find the slope between these two. 0 minus 3 over -1 minus -4. That gives me -3 over 3, which gives me -1. So my y value is equal to negative, I don't have to put the 1 there, I can just leave the negative, x plus 4, and then plus 3. And the last thing, I know this is not an equal sign here, we need to change it to an inequality. Well, there's a dotted line, so we know there's no equal to, and it's shading above the graph, so we know y is greater than, again, negative absolute value of x plus 4, and then plus 3. This is tricky here, guys. This is tough stuff. So if you have a question, please, please, please make a note of it, and then please ask us when you are available to. Okay. On part B, you don't have to worry about part B. If you want to answer it, do some reasoning, you're more than welcome to, but I'm not really concerned with that right now. I'm just really concerned with, do you know how to create the equation? Okay. So if you have questions, please, please, please ask, reach out to us. We'd be more than happy to help. From here, you can go ahead and do the lesson check or your homework quiz, whatever it may be called, and then feel free to go ahead and start the homework.